Hi everyone, today's video is going to focus on answering question 27 from the Maths Advanced CSSA trial paper. I thought this question was particularly good to go through because of its application of the trapezoidal rule, which has been a little bit uncommon in recent years. And I also find that in some of the students that I tutor, it's a very common mistake that some students are really unsure on like the meaning of sub-intervals and function values of trapezoidal rule and how to apply those effectively to answer a lot of different types of questions. So hopefully this video will help and clear some of that confusion up. So let's start going through question 27. Here we have a water is being used from a full storage tank to irrigate a garden, and the rate at which water is used may be modeled by using the equation R is equal to 50e to the negative root t plus 1. We're told that R is the rate at which water is used in litres per hour at time t hours. We're also told that after 2 hours, 5% of the water in the tank has been used. And we're also told that we want to use a trapezoidal rule with 5 function values to estimate the size of the tank and giving our answers to the nearest 10 litres. The first thing that's kind of striking out to me in this question is that this R value is already the rate. So we can kind of think about this as the first derivative function of it, and we're usually used to seeing equations like this when we see the rate in terms of dr and dt. So they've already differentiated some sort of R value, or maybe they've differentiated the amount of volume that's in the tank in terms of time. Because if I have a look at the next condition that they've given me, that after 2 hours, 5% of the water has been used, the water in the tank has been used, that's got less to do with the rate and more to do with the actual quantity that's in the tank. So I know that what I want to do is I want to get it from the first derivative form back into my actual volume form that I can find the equation from it. So therefore I want to find the primitive, I'm going to take the integral, and the question wants me to specifically use the trapezoidal rule here. So if we break this question down even further, we're told that after 2 hours, 5% of the water has been used. So if I'm looking at how much water has been used from the second to the second hour from the very start to the I guess when t is equal to 0. So here I'm going to say that the volume that's going to be in the tank, to the 5% of the water of the volume that's going to be in the tank, is going to be the integral between 2 and 0 of my R value in terms of dt. Okay, now I'm also told that I want to use 5 function values. So function values are the actual number inputs that you put into your trapezoidal rule. And then the sub-intervals is how many trapezoids are created from those function values. So if I think about my formula that's going to be used for my trapezoidal rule, which is given into your formula sheet here, we're told that the height is going to be b minus a on 2n. Now n here is the number of sub-intervals. So we can always think about it, the number of sub-intervals is always going to be 1 less than the number of function values that you have. So here if I have 5 function values, I'm going to have 4 sub-intervals. So with 5 actual endpoints to my trapezoids, I'm going to get 4 trapeziums here. So using that, I'm going to get the volume in the tank after 2 hours is going to equal to b minus a, so 2 minus 0, my upper limit minus my lower limit, over 2 times my 4 number of sub-intervals. And then I use the rest of my equation. So I'm going to get 50e to the negative 0.0 plus 1. So using my 0 when t is equal to 0. Then I do it when t is equal to 2. And then I do all the ones in between. So if I want 5 function values between 0 and 2, I'm going to go 0, 0.5, 1, 1.5, and 2. So these are the 5 function values that I'm using. And I'm just going to pop that into my formula. So breaking down that formula just a little bit, just kind of following what's in your formula sheet. Here, all these ones that are in the middle, so it's from 0.5 to 1.5, depending on how many function values you have per question, that's what you pop in between, you times them by 2. These ones sitting on the outside are your 2n limits. So you've got when t is equal to 0, and you've got when t is equal to 2 here as well. Then all you need to do is evaluate that into your calculator, and you get that the volume in the tank after 2 hours is approximately equal to 25.377259. So remembering that this is only the volume of 5% of the water in the tank. So if I wanted to find out what 100% is, I'm going to use the unitary method, which just strips it down to 1%, and then I times it by the amount of units that I want. So if this is 5%, like we said, to find 1%, what I would need to do to this answer is to divide it by 5. So therefore, 1% of the volume in the tank is going to equal to 5.075. Then if I wanted to find 100%, what I would do is I would times this number now by 100, and I get 507.54, and so on. And this question wants me to give my answer to the nearest 10 litres, so therefore we get my full capacity of my tank is 510 litres. Hopefully that helps you to understand the trapezoidal rule a little bit better. The main thing to remember here is that subintervals and function values are a little bit different, and we always can take one less subinterval than the actual number of function values that we have. Hopefully that helped.